This meeting is being recorded.
In problem 20 from chapter 3, we're given a structure for something called a disinfection byproduct. So that's what's given right here in the middle, this DBP. And we're told that this example that's given of a DBP has been evaluated for potential toxicity. So this compound has many constitutional isomers, we're told, as well. So we're asked to draw some of these possible constitutional isomers that could result from this specific DBP. So in part A here, we're asked to draw the constitutional isomer that would be slightly more acidic, and then give an explanation as to our determination. So to go from our original compound that's circled to compound A, this chlorine atom has been moved over to a carbon that is closer to the acidic proton. So that's what we see in structure A here. This carbon now has those both those chlorines, so two electron withdrawing groups closer to the acidic proton. So we have made this compound slightly more acidic than our original disinfectant byproduct. So let's remove some of these markings here, and let's take a look at what we're asked to do for structure B. We're asked to draw a constitutional isomer that's now less acidic and explain our choice. So we moved an electron withdrawing group closer from our original to structure A. So now if we were to take this chlorine atom and move it further away from our acidic proton to this carbon here, that's what we see down here. Both chlorines are now on the furthest carbon away from our acidic proton, so that would make this structure B slightly less acidic than our starting disinfectant byproduct. So now let's take a look at our original structure again, and the type of functional group that we should notice here is a carboxylic acid. And if you recall from table 3.1, the pKa values are approximately 5 or lower, depending on how many electron withdrawing groups you add to these carboxylic acids. And we're asked in part C to draw a constitutional isomer that would be significantly less acidic. So at least 10 pK units. So what we can do is consider changing to a different functional group. So carboxylic acid, in the name as it implies, is pretty acidic. So if we were to change our structure, as we've done in molecule C over here, to what looks like a hydroxyketone, we can have a significantly less acidic compound. So ketones in general will have a much higher pK and therefore would be much less acidic.